Yeah, good morning all. Now I would like to discuss about electrical machines. Okay, here electrical machines are majorly classified into two types: DC machines and AC machines. Okay, this DC machines also again classified into DC generators and DC motors. Okay, again here AC machines also again classified into transformers, three-phase induction motors, synchronous machines. Okay, now first we will discuss about DC machines. Okay, DC machine converts either mechanical energy into electrical energy or electrical energy into mechanical energy. Okay, that is the conversion principle of DC generator. Okay, if a machine which converts mechanical energy into electrical energy, that is nothing but a DC generator. Okay, if the machine which converts electrical energy into mechanical energy, that is a DC motor. Okay, next coming to working principle of a DC generator. Okay, let us consider a magnetic field. See here, this is north pole and this is south pole, right? Here flux lines will pass from north to south. Okay, let us consider a current carrying conductor having a current I. Okay, now see here, whenever a current carrying conductor cuts the magnetic flux lines, see here, this is the direction of flux lines, right? Okay, this is the direction of conductor, right? Okay, whenever a conductor cuts the magnetic flux lines or magnetic flux lines will cuts the conductor, EMF will be induced, that is dynamically induced EMF according to Faraday's law. That is, whenever a conductor cuts the magnetic flux lines, an EMF is induced on that conductor. Okay, this is according to Faraday's law of dynamically induced EMF. Okay, mathematically the dynamic induced EMF is given by E is equals to BLV sin theta. Okay, where theta is angle between magnetic field and current carrying conductor. Okay, now see here, the direction of induced EMF is identified by using Fleming's right hand rule. Okay, Fleming's right hand rule indicated that stretch the forefinger, middle finger, thumb mutually perpendicular to each other. Okay, clear? Forefinger indicates direction of flux, middle finger indicates direction of induced EMF, thumb indicates direction of motion of conductor. Okay, that is about Fleming's right hand rule. Okay, that Fleming's right hand rule is used to identify the direction of induced EMF. Okay, clear, right? Next we will discuss about construction of a DC generator. Now see here it is the schematic arrangement of a DC generator. Okay, this outermost part is a yoke. Okay, now these are the field windings. Okay, this is pole core, this one is pole core. Okay, this is pole shoe. Okay, this is armature core. Okay, this armature core consisting of armature slots. In armature slots we are placing this dot represented by armature winding. Okay, next, now see here, this is inside one will be shaft, these are the brushes. Okay, next these are the commutator segments and here it is a commutator. Okay, now we will discuss each and every part clearly. Now see here, first of all, when DC supply is given to the field winding, this field winding will produce a constant flux of phi. Okay, this flux will pass from here, this is the direction of flux lines. Flux lines will pass from north to south. Again here also flux lines will pass from north to south because of the presence of this DC supply, right? Now see here, when DC supply is given to field winding, it will produce the constant flux. Okay, the produced flux will be cut by these rotor conductors, hence EMF will be induced on rotor conductors. In this way DC generator is working. Okay, now see here, first we will discuss about each and every part. DC generator essentially consisting of yoke, field winding, pole core and pole shoe, armature core, armature winding, commutator and brushes. Okay, this outermost part is nothing but a yoke. Okay, yoke is made up of with cast iron for small rating machines and cast steel for large rating machines. Okay, the purpose of yoke, see here, it provide a return path for the magnetic flux length, or it provide low reluctance path for the magnetic material. Okay, that is first point. Next, second point, it acts as a protecting cover for the entire machine. Okay, that is about yoke. Next, second one will be field winding. This is the field winding, right? Okay, field winding is placed on the poles, right? This field winding is connected in series. This field winding is excited by DC supply, right? This field winding is excited by DC supply to produce a required flux in the transformer, sorry, in the machine. Okay, next, pole core and pole shoe. Okay, pole core and pole shoe are attached by countersunk screws. See here, here pole core and pole shoe are attached by countersunk screw. Here pole core need not to be laminated, whereas pole shoe is should be laminated. Why? Because there should be a flux variation. Here air gap is non-uniform, hence pole shoe should be laminated to reduce eddy current losses. Okay, next, armature core. See here, here this one is the armature core. Okay, armature core is made up of with silicon steel laminations to reduce both hysteresis and eddy current losses. Okay, next, armature core consisting of armature slots, right? In armature slots we will place the armature winding, right? Here hysteresis loss is nothing but hysteresis loss is due to reversal of magnetization. Okay, next, eddy current loss is nothing but eddy current losses are due to presence of eddy EMF. That means while in case of DC generator, whenever a conductor cuts the magnetic flux lines, EMF will be induced, right? In this process there is some EMF induced on the additional parts of the machines. Okay, those EMFs are we are unable to measure it. Those are nothing but eddy EMFs. Because of those eddy EMFs, there are some eddy currents present in the additional parts of the DC generator. Those are nothing but eddy currents. To reduce eddy current losses, this core should be laminated. Okay, by using silicon steel material we can reduce hysteresis. By using lamination technique we can reduce the eddy current losses. Okay, next, armature winding. These armature windings are a former wound coils, okay, placed in armature slots. Okay, those armature conductors are insulated each other. Okay, that is about armature winding. Next, coming to commutator. Okay, the purpose of commutator is to convert AC voltage into DC voltage. Okay, next, brushes. Okay, the brushes are made up of with carbon or graphite. Okay, see here, these are the brushes, 4 brushes, right? The 4 pole machine carbon, 4, here it is a 4 pole machine, then it is having 4 brushes. The purpose of brushes is to collect the current from the armature conductors. Okay, that is about construction of a DC generator. Okay, thank you all. Remaining we will see in next class.